Hello, everyone. Thank you for joining us today for the demonstration of our project, the Latent Probabilistic Model of News Sources. Before we dive into the demo, let's start with a brief introduction to our sponsor and the team. The team consists of 3 seniors at Washington State University. My name is William. I'm a software engineering major,
I'm Gabriel Sams. I'm a computer science major.
I'm Devin Beeler. I'm also a computer science major.
and that's our team. Now let's move on to the heart of the project. A word about our sponsor. Our sponsor is the U.S. Army Cyber Institute, with senior research scientist Ian Cruikshank as our mentor and primary contact for the project. They play a critical role in modern military operations, and they approach us with a unique challenge. The Army needs a method to evaluate media landscapes without relying on subjective opinions or internal publishing knowledge. Project problem statement. The problem we aim to address is the challenge of evaluating media landscapes without relying on human biases or subjective judgments. The increasing concerns about media bias and its potential impact on society, coupled with the critical role of information in military operations, prompted our sponsor to seek a data-driven solution. In today's age, misinformation and biased news can have significant consequences. Our sponsor recognizes the need for an unbiased, empirical method to assess media landscapes and understand the biases present in news articles. Our tool aims to fight misinformation by providing industry professionals with an unbiased tool to quickly analyze large sets of news articles and give insight into the media landscape these articles belong to.
Let's move on to the functional requirements. First off is web scraping. The model must take in a CSV of URLs and then proceed to scrape the article data from the internet. It stores all articles' text and title in a data frame for the rest of the model to use. We have per topic sentiment analysis, which allows us to accurately estimate an article's opinion on a certain topic and compare topic sentiment between articles. We have per article sentiment analysis, which gives us a more robust understanding of the bias of an article as a whole, and to compare articles without having to include specific topics. Topic modeling. We model relevant topics to determine the topics, which is essential to model a per topic bias analysis. The model creates an optimal set of topics that span the entire document corpus, such that every article can relate to at least one topic. We also perform similar article analysis, where we can compare and contrast articles based on their major topics to better see how certain articles differ in their biases and what they talk about. We also have data visualization, where the model must provide a visual insight into the media landscape generated by the previous steps. It generates several data objects as well as visualizations to help users understand the topics and the sentiment of the articles used as input. This is the main output of the model. Next is our non-functional requirements. The tool must prioritize delivering accurate and reliable information consistently. The tool is designed to be extensible to other domains within online media, accommodating new languages and political environments through user-inserted tools and libraries. The tool emphasizes usability by providing an instruction manual and documentation on how to run the model. Centered on analyzing the actual content of news articles rather than contextual elements, the tool excludes considerations like authorship or timing to make its calculations. And finally, the tool aims to deliver highly comprehensible data for interpretation by industry professionals to support informed decision making in a business setting. Now we have our project design and solution. Our high-level design involves creating a probabilistic model based on biases and sentiment values within news articles. Python is our language of choice, leveraging popular tools like Spacy for NLP, Gensum for topic modeling, TextBlob for sentiment analysis, Pandas for data management, and Newspaper 3K for web scraping. Our implementation of the solution. As the project progressed, we incorporated sentiment analysis as primary drivers in determining bias. The goal is to create an objective model that characterizes news sources based on empirical data rather than subjective judgments. It also utilizes LDA topic modeling to create a topic space, which shows how articles relate or differ by their topics. These factors combine to give us helpful data visualizations and several data objects. As of November 30th, we have successfully delivered a media landscape assessment tool to our sponsor. The solution provides insights into biases and major topics within news articles and sources, aiding the Army in understanding online media environments.
Now let's jump into our live demo of our application. Please visit our GitHub to explore the tool directly. We'll also show a quick run of the Python notebook.
In this first code block, you see our installs for the initial setup, followed by our library imports, as well as the files that the program relies on. After that is our settings section, And after the settings, our main pipeline starts. In the main pipeline, we do our sentiment and subjectivity analysis. And after that is done, you get an output of how many articles were scraped successfully, along with the average sentiment and subjectivity score.
Using that output from the previous step as input into this, we create a topic model, which models the topic space of the article corpus. We generate an optimal number of topics based on the relevance score of the topic model. And then we move on to data visualization. Here we pre-process our data frame to fit within our data visualizations, as well as creating some new data objects to help with the visualizations. Here is our settings, and here is our actual visualizations. Here we show the data frame with all of its data as well as all topics. We visualize all of our articles as well on their main topic, sorted by main topic and measured by sentiment analysis. Next, we move on to the models of the topic space and topic space with sentiment analysis using both TSNE and k-means clustering to model the topic space. We do a measurement of subjectivity versus sentiment for all articles on a single topic, as well as providing the word cloud to better understand what that topic relates to. Here is our k-means generation, where we generate an optimal number of clusters based on the inertia score of the number of clusters we make. And then we move on to the k-means clustering and visualization of the topic space again, where we provide a 2D and a 3D visualization.
Here's where we multiply our relevance by our sentiment score, so we can look for latent sentiment and bias in our corpus. Here's where we compare the sentiment versus relevance per topic. Here's where we create our topic space. After our PCA is done, we plot the PCA on a two-dimensional plane. And then we plot the topics on top of that, as well as their sentiment according to the color. We also look at how dense the area of the clusters of documents are. And here's where we introduce a sentiment as well. The possible future work for teams include develop a user interface for the model, leverage the modular nature of the model for testing new libraries and tools, explore the addition of article similarity feature to the model, consider the possibility of creating a research paper based on the project. Thank you for your time today. We're proud of what we've accomplished, and we look forward to seeing how this tool evolves in the future. If you have any questions or feedback, please feel free to share them. Thanks for watching.